but thank you guys for coming. It's really a dream come true for me to be here and talking about my ideas with you all today. And so, although this is a workshop, we're going to be formatting it more as a lecture, so you guys just have to sit there, relax, smoke your dupes, have your drink, and just relax. And if you want, I passed out those. You can look at the graphics along the way, and I'll be pointing at it, and so you guys can follow along. So, I want to let you know that there will be no pop quizzes or homework for this lecture. I'm simply just going to be stating the theories and examples, so it's easy for you guys to digest the information. And so then, I'm sure now you're wondering, like, who the heck is this guy, and why does he have the right to talk to us about this shit? Well, my name's Richard Pound Fernandez. I'm from the United States, but I've called Australia my home for the past 5 years, and I love it here. I've done 4 years of physics, I have a scholarship at Swinburne to study physics for the past 2 years, and I did 2 years in the States before I came here at UNCW. Hello guys! We just started! Oh, I don't give a fuck. Here you guys go. I'll give you a couple more pass-outs. I'll let you know when to open them. There you go. You guys just came up with
like this.
There you go. And then take us out.
Marijuana.
So that's my practice in physics, but spiritually, at the age of 12, I took my first Reiki class, and after I took Reiki, I found another teacher that specialized in environmental energy work. So I have about 2 years of practiced and taught energy work, but I've been doing my own practice since then. But learning those things at a young age made me lose a lot of friends, and it kept me silent. And I'm really happy that I'm here in confidence with you all, talking to other like-minded people, and that I can gather my thoughts together, and I really can't wait to share it with you guys. So before we get started, I want to do another disclaimer about what science is. Science is not the truth. It is the search for the truth. And I just hope that my lecture speaks a bit of truth for you. A true scientist would want nothing more than to be proven wrong. They just want to know what the fuck is up. I can tell you, 500 years from now, I'm sure some of the things I'm saying might not be true. We'll just discover more and more. The universe is a very complex place. But either way, we have a very firm grasp of what our reality is at this point. So at this point, you can go behind the cover page and pull out the slide. And we're going to talk about our first concept, which is, what is energy? Does anyone want to take a crack at it before I go at it?
Which one's the front?
Oh, just take out, so inside the sleeve, there's a piece of paper behind the title page. Is there only one paper in there? No, there. So take out, yeah, you got it. Does anyone want to take a crack at it?
Vibration.
Yes. Energy is everything. So energy is an intangible and invisible substance that makes up every single thing in our universe. When you collect enough energy together, it produces a force on the environment around it. So in short, energy is the ability to do work on the environment around you. Did someone just snap? That's so cute. So we can take a look here, and I thought I'd include this in the slide, this famous equation, E equals mc squared. And I thought it'd be cool for you guys to know what this actually means, and why it's so important in fundamental physics. So E is energy, and energy is equal to mass times the speed of light squared. That means you could take your weight, let's say you weigh 80 kilograms, multiply it by the speed of light squared, and you'll find out how much energy is inside of you. And truth be told, there's enough energy inside your body to power Victoria for the next 3 years. So a lot of complicated things went into making all the atoms in your body. And some of you might be thinking, why the speed of light squared? And that's the thing about physics. We don't know why. That's just what it is. Scientists aren't concerned with the why, just with this is how the world operates. It's the speed of light squared. We're not very philosophical about it. And so energy takes on two forms. It takes on many forms, but there's only two main ones that you need to think about today. kinetic and potential energy. And you can follow along with the rock, because I'll be demonstrating with a rock. I know, I'm a dad already. So, kinetic energy is energy that is a form of energy that deals with all things in motion. So that's like a car moving, or a rock falling a distance, or electrons spinning around an atom. When I drop this rock, it has 0 kinetic energy up here because it's resting, but it gains kinetic energy as it's falling due to Earth's gravity. And it reaches its maximum kinetic energy right before it hits the ground, before that energy gets dispersed into the ground. Energy conserved, but not forgotten. Energy can't be destroyed. The next one is potential energy. Potential energy deals with stored energy. This is energy that is inside something that's ready to be expended but hasn't been expended yet. That's like the rock I'm holding in my hand. It knows that it's going to drop this distance but hasn't done so yet. It's like an atom that's ready to split in an atomic bomb, an unstable one. Or it's the food that you eat. Food has potential energy inside of it. You eat it, and then it breaks apart as kinetic energy in your body, and then you can use it to do all your daily tasks. So with that, we can get a good idea for the rock system. And you can follow along here at the diagram. You have a thought in your head as potential energy to pick up the rock. You transfer potential energy from your head into kinetic energy into your arm to pick up the rock. As you pick up the rock rock gains potential energy, and you're adding energy into the system. And the higher you go, the more potential energy is inside the rock. And when you release it, all that energy that you put in your body into the rock dissipates into the ground. And all this can be measured in kilojoules. It's in the food you eat. And so, why I think it's important to understand how energy transfers is this allows you to become a master of the environment around you. Understanding how energy transfers between objects can allow you to become a master of your world and be more of a critical thinker. Does anyone practice massage in the crowd, or massage therapist? No one? Well, this is how you can take whenever you give your partner a massage to the next level. You can have a thought inside your head as potential energy to give treatment to someone, to give love, to give healing. And you can transfer that potential energy in your head into kinetic energy into your arms and transfer it into their body. It's a very simple energy technique, and you've been doing it your whole life. But by being mindful about what you're doing, you can make your practice extra potent. And you can do this for many things. You can do this for cooking a food for your friends, adding kinetic energy through your thoughts into your food. It's why it's made with love. That's what people say. You can do it when you're planting a seed into the ground in hopes that it'll grow. You can really apply this logic to almost anything. And by understanding how your mind works and how you interact with the world, you'll be able to live a much more, I believe, rich life. All right. Give me a second. I'll just go to the next slide. Let's see. So next we're going to talk about my favorite part, and that is what your aura is made up of, and what I like to call your area of influence. So your aura is made up of hundreds of different energetic layers, but we're just going to be talking. Oh wait, sorry. Does anyone have any questions? I'm just talking and talking and talking. If you do, just fucking go like, shut the fuck up.
You know, like, a thought is potential energy.
Yes.
Is that like, does a thought have mass?
Well, so a thought, yeah, it does. So when you collect energy together, it creates a force in the environment around you. So a thought is like kinetic and potential energy, if you want to get technical about it, because when you have a thought, there's neurons firing in your brain, those neurons are moving, and that creates kinetic energy, and that creates a pulse inside your head. But it's just like you have all this potential energy inside your body waiting to be expended. Like when you eat food, you have all this stored energy in fat and ATP, if you know biology, but it allows you to go for a run, it allows you to cook your food, it allows you to do all your things. So if you had no potential energy inside your body, you'd be dead. So keep eating, keep drinking water, kids. Any other questions? That's sweet. So your aura is made up of two main energetic layers that we'll talk about today. And the first main one that I'll talk about is your gravitational your gravitational fields that you give off. Anything that has mass gives off a gravitational field. Let's see. And these gravitational fields radiate out of the various centers of mass in your body. So right here is a center of mass, around your arm is a center of mass, here's a center of mass. And what's great about gravity is that these waves radiate infinitely out around you. They're more powerful the closer they are to you, but you are in contact with everything in the universe through these waves. And so what that means is that you are just like the sun is to the earth, you are pulling everything in the universe towards you, and the universe is pulling everything, and vice versa. The universe is pulling on you, and you're just in a sweet equilibrium right now. But you are constantly doing that. So if I could get a volunteer to come up here and give me a hug. Anyone? Come here, Em. So if anyone felt that, what happens when you combine masses together? The fact that we might nearly weigh the same means we just double our gravitational influence. You being as a collection here together have a stronger gravitational wave giving off than you just alone. Just like the people at the dance floor when they collect. It might be why you just like, whoa, what a vibe. This is really sick. Because of the collection of masses. Just like buildings in the Melbourne CBD, they collect and they radiate a stronger gravitational wave. The next more dynamic part of your aura is your electromagnetic field. So this deals with the magnetic fields that radiate outside your body due to electricity. So I'll explain electricity real quick. You have, so your blood, your nervous system, and neurons. Hello guys! Are you here for the lecture or just fucking chilling? Yeah? I got a couple, let's see. Please sit down and share, make friends if you want to, or someone is happy with just sharing. We're nearly like a third of the way, halfway through, but I'm sure you'll still get a lot out of it.
Yeah, continue.
No worries. Let's see, let me collect my thoughts. So you have electricity running on your body due to your blood, nervous system, and neurons in your brain. And how electricity works is that wherever there is an electric current running, there is a magnetic field that radiates circular and perpendicular to the direction of the current running around it. You can think of it as a train going through a tunnel, where a train is the electric current and the tunnel is the magnetic field around it. So you have magnetic fields radiating around your arm here due to your bloodstream and nervous system, and around your body here. You can see it in here as the blue arrows at the bottom here. Cute. I think it's pretty cute. Let's see. And so, electricity is generated in your body due to a unique property of metals. And so I'll tell you how metals work and why they're so unique compared to other elements. Metals share electrons willingly with each other. Like where one electron doesn't belong to one metallic atom, but belongs to the whole system as a whole. You can think of a metal bar of gold as a sea of electrons rather than just one belonging to one. It's like lighters in a share house, they don't belong to anyone. They're just floating around. And so you have metals in your blood, nervous system, and neurons, and these are firing off at all times. So when I touch my fingers together like this, a signal is fired through my nervous system to my brain and then back down to my fingers, inducing a brief electric current and therefore a brief magnetic field. But your nervous system is firing off at all times. You have 1.3 megabytes of information being sent to your brain every second. And what's interesting about this is that this information and your blood running change depending on your emotion. When you're angry, your blood runs hot, your nervous system's firing off. When you're sick, your nervous system is going off. When you're relaxed, your blood is slow, your nervous system's relaxed. And these different currents send out a varying magnetic field to the environment around you, meaning that you are projecting your emotions to everyone at all times. So this is why some people might be able to walk into a room and be like, oh, this is not a good vibe. It's because you're feeling all the different magnetic fields in there. It's like all the emotions here. It's like, or you can be an empath and relate to people. It's because of these very gives off due to emotions that you can feel. And that's why we have empathy. It's cute. I think it's all very, very cute. And so an interesting thing about metals is they share electrons with each other, which means in turn that when you make contact with other people, you exchange electrons with them as well. That's why it's so important that when you meet a stranger, you shake their hand. When you shake their hand, oh yeah, if anyone wants to follow along, it's right there, on the back. So when you shake someone's hand, you exchange electrons with that person, meaning that you are now part of them and they are now part of you. And it's almost like, it feels weird not to be in contact with someone. You have to make that initial contact, otherwise it's just like, oh, I feel weird, I don't know who this person is. It's why we like to hug, it's why we like to kiss, it's why we like to make love. It's like, you get this exchange, you get to be a part of this person. So at this point, I'd really love for everyone to keep in mind that when you hold each other, you're making an exchange. And I'd love for everyone to hold hands with the person next to them. And I'll have everyone have a little moment. So I want everyone to have a little bit, a moment of silence, and be mindful. And think of the space when you're holding someone's hand as negative, and there's this exchange that's happening. Whether you've done energy work or not, and whether you're mindful of it or not, you are exchanging electricity with the people around you. Thank you, guys. So, everyone holding their hands together, you have an electric current. Let's say that your body's producing 1 volt of energy. When you hold hands with someone, everyone here just produced enough energy in here to that of a tiny battery. Not much, but it's still significant to me. And you don't even have to be in contact with people for you to exchange electrons with each other. Just like gravitational waves, your magnetic waves radiate infinitely out around you. So I'll give it a little example so you understand. If you go into the vacuum of space, and there's only 2 atoms in the vacuum of space, let's say they're hydrogen or something, let's say it's gold, doesn't matter, and they're hundreds of kilometers apart. The fact that they're the only 2 things for light years away, they exchange electrons with each other, just because they're the only 2 things close to each other. So scientists found that although you share electrons more readily with the people and things that are readily around you, you share electrons with everything in the universe. So you're exchanging electrons with the sun, with Mars, Andromeda Galaxy, everything. And although it might be happening at a tiny rate throughout your lifetime, you'd be surprised at what sort of electrons you get in contact with. And if there's any travelers among us, I can teach you a neat trick. I used to walk barefoot for 5 years of my life, because after my physics professor taught me this, I was like, oh, that's fucking sick. So when you take off your shoes and you're in contact with the ground, you exchange electrons with the ground around you. And scientifically proven, you can beat jet lag by taking off your shoes in the new time zone you're in, because you get accustomed with how the electrons are vibrating and the frequency on that side of the planet. So like, yeah, easy, walk around barefoot wherever you are, doesn't matter if it's a city, like it can even, so.
They say we're Australians, it's a law in Australia.
Yeah, a lot, exactly. It's like my people.
I think it should be a law, yeah.
Yeah, take off your shoes.
No shoes all the time.
Yeah.
Yeah.
So you can exchange electrons. Huh? I did it for 5 years, and I've calloused. Yeah, it's, huh? Oh yeah, it works.
You didn't get
You just got calluses or like go jet lag?
Yeah, sure.
Oh, I got both.
You didn't know 5 years ago.
I'll show you.
Do you do mine?
But
Yeah,
no
go
jet
for
lag.
it. No jet lag.
Oh, yeah.
Oh, they're a little moist because I'm allergic around here. Yeah, we're doing our best. And so you can exchange these electrons more readily with sand, concrete. You can still exchange it with plants, like walking on the grass, because plants contain metals inside them as well. All living things have metals in them to exchange signals to keep them alive. but mostly other metals is how you're going to exchange more electrons with.
So like more so like in like a CBD type sort of thing. Like if you fly from one side of the world to here and jump off, just jump straight across, it would be like more so to be jet lagged.
Yeah.
If you jump off barefoot.
Yeah, so I recommend, I think the best, yeah, exactly. So concrete's good as soon as you get off the plane, start doing it. But you can also go to a beach and put your whole body in the sand, and whatever contact is in with the sand, because sand just gets everywhere, you'll exchange electrons a lot faster and get accustomed. And you'll get rid of your Australian electrons, literally. And like you'll be like, I want to be Berlin. And just get in it. All right. Are there any questions before I go to the next topic?
I'm assuming water is a great conductor as well, like because you said sand. Does it have to be the earth, or is water?
So water by itself is funny. So if you have
Like
pure
salt
water,
water.
yeah, salt water,
Salt
perfect.
beach. Yeah.
So waters, why they're electric is because they have metals distilled in them.
Yeah.
Pure water doesn't conduct the electricity, but water's conductive because of how much shit gets dissolved in it. So water's perfect as well, going for a dip in the ocean or a pond, or putting your arm, like washing your hands and stuff. Maybe because like the water pipes are underground, not so much, has to be in contact with the sun.
What happens to the electrons that you exchange, the ones that leave you?
They get replenished. So when one electron leaves your body, another one comes in. So you constantly have the supply. And so that electron that you now put into the ground or whatever just starts floating around and goes into equilibrium with the other electrons around it. Yeah.
So is there like the purest place to like say to fly somewhere?
Yeah.
The purest place to fly, and then jump off, like next minute you're in the beach, so you hear something up, just like feel like having a good time.
Yeah, exactly. It'll be trust me, it works. It's good. It's good stuff. Did you have a question?
It was the same question.
Oh, sweet.
Yeah.
Hello.
Hello?
How's it going?
You'll do it up.
We're fucking killing it. We're having a good time. I'm doing a physics lecture if you want to sit down and enjoy yourself. I'm just about to do the last little leg of it. So, what quantum mechanics is the study of probabilities. So whatever you are not witnessing with your five senses is doing something completely different. So we'll just, for the most part for the lecture, we'll just talk about sight. So whatever you are not looking at goes into a quantum state. Every subatomic particle around you. It relaxes. So I'd love to do a little thought experiment. If I can get a volunteer from the crowd. Someone? Fuck yeah, get over here. So what I'm gonna do is I want you to think consciously whether you are gonna take this shot or not in your head.
He already knows what he's gonna do.
Oh, great.
So just don't say to anyone, just think about it. And I want you to go behind the red tent over there. And I'll speak up so you can hear as well.
Behind it?
Yeah, behind it so we can't see you, or the top half of you. So, what happens when he's behind there is we're not witnessing what he's doing. So he is in a quantum state. What happens is that there's a 50-50 scenario. Either he takes the shot or doesn't take the shot. And in quantum mechanics, both are real and happening at the same time. Both realities are real. And it isn't until that he comes back around. You can come back now. Whether he reveals he took the shot or not.
We're all wrong.
Fuck! What? I can't bring glass.
Can I have a shot?
Embrace reality. Good stuff. This is a quantum shot.
There's a 50-50 chance.
It's a 50% chance this will get you drunk, whether it's water or not.
Good thing I didn't just throw it at my shoulder.
Oh, a third possibility. So if anyone's heard of Schrodinger's cat, that's the same thought experiment. When you put a cat inside a box with the bomb, it either triggers the bomb or doesn't, and until we open the box, we don't know.
So does that mean that there's a reality where he has taken the shot and where he hasn't taken the shot? Both happen?
in science we don't know. But we can. So I'll explain this. The quantum mechanics only applies to subatomic particles, but we are made of trillions of them. So, for example, when we first saw quantum mechanics at work, was a scientist was looking through an electron telescope and was like, okay, we know the electron is right there. But he keeps the machine running and he keeps the data going, and he turns around, and then the electron is over here, it's over there, it's over there, it's over there, it's over there, it's over there. So it has like a 30% chance of being over there and a 70% chance of being over there. And literally both are happening at the same time. The machine is recording it. So it isn't until that we look back at the electron that reality crashes in on itself and shows us what's actually happening.
So it doesn't happen. So both things don't happen.
Both are happening at the same time. No, both are, but these, yeah, it's really weird. So both realities are happening.
So where are we in the other one?
Well, you're constantly witnessing yourself, so you're always together. Like, as long as your senses, your 5 senses, are witnessing the world around you, the world keeps itself together. But whatever you're not experiencing is doing something really fucking weird.
We don't know what it's doing, sorry.
Yeah.
But like, so with like, you're talking about sight, yeah? So
Yeah.
like when we see, we're not like actually looking at everything really detailed, like the details on the blade of grass and all that
Yeah.
thing, but our mind on a quantum level is creating it all
Yeah.
as we're moving through, but we haven't gone and like viewed like that tank down there to see if it's like solid, but as we move through, it's like creating it, yeah?
I'd
It's
say
like
that's
quantum.
I think it's a good way to think of it.
Yeah.
I'm not, like I can't
if
confidently...
everything's happening, you know, like that nature's like blowing the wind and the like things are rustling, but sometimes when you're just on the path to the dark gallery or something, you're not like really looking at the details of it, but it's happening. you
Yeah.
know?
Well, so then we just deal with probabilities. So
Yeah.
we just go like, all right, so when I'm given a quantum physics problem, I go like, okay, these are all the variables, like what is the neuron doing or what is the neutron doing? And I can go like, okay, it has a 20% chance of doing this, it has a 30% chance of doing this, and it has a 50% chance of doing this. And it isn't, and so then you just try to guess what these subatomic particles could be doing, and that's the big basis of quantum mechanics. Yeah.
So if a tree falls in the woods and there's no one there, does it make a sound? Or-
It does make a sound.
It does.
Yeah.
Yeah.
I can't really accurately say whether or not because no one's there, but the tree has senses.
But there is a tree there.
Yeah, but the tree has senses, it's alive, it communicates with the world around it, it has electricity running through its body, it has energy, so it's witnessing the world, so the world is put together. Yeah. So I would imagine that whatever could hear it, whether it's like a frog or the tree itself, I don't know, like, it would make a sound. The spider in the tree!
Shit, this it doesn't say ouch.
Huh?
It doesn't say ouch.
Yeah, it doesn't say ouch, no, the tree's just... Let's see. So yeah, it's almost like the universe. It's really interesting because the universe basically tells us that it just wants to relax. It doesn't want to use a lot of energy unless it has to. So while it's not being witnessed, it's like, ugh, finally, like I can let my hair down. Like it's just like, it's literally just like, oh sweet. And then until it's like, oh shit, she's coming. It like, puts its makeup on and shows you what's actually happening. So the universe is really lazy, and that's what, yeah, quantum mechanics is a good representation of it. The universe is just a very lazy place. Another part about quantum mechanics is that we can only know 50% of all the information in the universe. So, what that means is that the universe is categorized into 2 different categories. We have physical properties and wave properties. Physical properties deal with its weight, its velocity, how much energy, all things physical to do with the rock. And then there's wave properties, which deals with its wavelength and frequency. Everything gives off a frequency. It's radiation, things like that. So what that means is I could weigh this rock, and let's say it weighs 1 kilo. And it's like, sweet, I know that it weighs 1 kilo. And then I go and I measure its frequency. As soon as I know what its frequency is, let's say it's 1 hertz, hertz being a unit for measuring frequency. I measure its unit for frequency. Then its weight goes into a quantum state. And because so many things could give off the same frequency, it now could weigh 1 kilogram, it could weigh 2 kilograms, it could weigh 3 kilograms. And it isn't until I weigh the rock again and go like, okay, it weighs 1 kilogram, then its frequency goes into a quantum state, and it could be 1 hertz, 2 hertz, 3 hertz, 4 hertz. It just could be anything. So the universe is only 50% attainable, and it's really down to the 50%. So when we're doing our quantum problems, we'll be like, all right, so I know its physical properties, that means it could have these different frequencies. Or I know its frequency so this particle could weigh this much. So it's probably an electron, or maybe it's a neutron. Something like that. Any questions on that? Or anything else?
Yeah, like one more.
Yeah, go for it. I'd love it.
So will it ever be possible, or will it be possible for us to observe the non-collapsed version of the universe? You know, like
Not without machines. Because us as sentient beings, there's something about us witnessing it and being alive that makes the universe want to put itself together and show us what it looks like. But machines are different. Machines can witness quantum states and can measure them.
Yeah, because the viewer changes everything in quantum mechanics.
Yeah. What do you mean? Sorry.
Is it just because we witnessed them through?
Yeah, it's because, well,
How do we
yeah.
know this one's the machine? Like us observing?
How do
Well, we
trust
can look
them?
at, we can make many different machines. Let's say we make like 1,000 machines and they all give the same results.
Just us interacting with it.
Yeah.
So then the machinery isn't exchanging.
The machine is just witnessing the atom, that like it's in a very isolated state. So when you have like a machine that's witnessing atoms, it does a very good job at making sure that nothing else is interacting with it. So you can imagine there's like the atom there, and then there's a vacuum around it where nothing can interact with it, and maybe some other metals to make sure that no magnetic fields affect it. But the atom is very isolated, and we basically just have like a camera on it, just watching it.
It's like the knowledge of the atoms behave differently when observed.
Yes. Very sick. And like I said at the beginning, like this is what the science we know now, but of course in 500 years from now, these ideas could be completely different. But this is just what we know now. And it's very abstract, it's very weird, but this is the way it is. So another part of quantum physics is quantum entanglement, which I think a lot of you people will really love this idea. Quantum entanglement states that anything that was part of the same system will always be connected. So we can take electrons. Let's say there's 2 electrons spinning around an atom, and then we separate those electrons by a distance. Because they are a part of that same atom and they were connected, will always be connected. So that means whatever you do to one electron, it will do to the other electron at the exact same time, which breaks all classical physics. Because as far as we know, everything takes time to happen. It takes 8 minutes for light from the sun to reach Earth. That means if an alien race stole the sun, it would take us 8 minutes to figure it out, and by then, it'd be too late. It takes milliseconds for sound to reach your ear. Everything in classical physics, everything that I taught about before this, takes time to happen. But not quantum entanglement. Quantum entanglement happens instantly at the exact same time, which physicists are just like, holy fucking shit. And what's interesting about this is that we were all a part of the system at one point. So, for one, we were all part of the same star before it blew up and made our solar system. But we can take it further to the Big Bang, when we were all part of one system. Quantum entanglement now dictates that you are now connected to everything in the universe through quantum entanglement. Instantly, you'd be able to feel the things around you if you're open to it. You can feel the moon, you can feel the sun, you can feel the earth, you can feel distant things if you're open to the idea. I've experienced it myself once I learned this idea, and it's incredible.
Everything's happening in the now.
And my partner the other day brought up a great question, is if we're all connected and quantumly entangled, how come we're not all doing the exact same thing at the same time? And it's a great question. And it's because, if anyone's heard of entropy, our universe is very chaotic. So there's lots of things happening out there. When the Big Bang happened, we blew up. Everything is so chaotic and everything's just trying to get to equilibrium. If you look at how the universe is going, it's going to be very quiet in a few trillion years. Everything's going to be really stagnant, everything is going to be burnt out, and there's going to be barely any black holes. So things are trying to get all connected again, but everything's so chaotic. The moon is cold, the sun is hot, that they're in equilibrium. They're trying to get into equilibrium with each other, but it's just going to take a really long time for it to happen.
So is that where people are
Yes. And some people might not be sold on the idea of the Big Bang, and I'm not really either. But I can talk about why we think it's real and why we think the Big Bang happened. So there's two theories that help tell us that the Big Bang actually happened. One, we can look through telescopes. The further you look out into a telescope, the further into the past that you see. And as you look further and further into the past, you look billions of light years away, you start to see like a movie in reverse of the universe like birthing itself. Like she is fucking killing it. But so we can look further into the past and see galaxies getting closer together, them dissipating, more clouds of dust. But there's only so far that we can see because of how dirty it gets. But there's new telescopes that can see a lot further. And it's very interesting to see those photos. Another thing that we know, how we know the Big Bang might happen, is something called red shifting. So I'll put this down. When a car passes you, it sounds like meow. And what happens is that when a car is coming towards you, the sound waves it's giving off are getting compressed. And as it's passing away from you, those sound waves are getting stretched as it's moving away from you. And this the same thing applies to light. So galaxies that are moving towards us are higher frequency. Their light is getting a little smushed, so they look a little bluer, because blue has a high frequency. Galaxies that are moving away from us give off a long frequency, so they look a little red, because red has a long wavelength and has a long frequency. And so what we see when we look further out is like if we look just one light year away, like things are moving all over the place. But if we go out far enough, every single galaxy is moving away from us at an accelerated rate. So that means every single second, galaxies are moving away from us faster and faster and faster and faster. We can calculate how much energy it would take to get all mass in the universe to expand at an accelerated rate. And the amount of energy it would require for our universe to do that is to have every single atom in the universe condensed down into a sphere thousands of times smaller than an atom. And so far, that's the only way we're just like, that's the only possible way this could happen. So it's not like that we witnessed the Big Bang, we're just like, okay, so these are the variables that we have. We have acceleration, we have all the mass in the universe that we can see. It would require all this pressure for it to expand out the way that it has. Whether that's true or not, we'll probably be dead by the time humans figure it out, but I'm happy for them. Unfortunate. And who knows what kind of discoveries that will make. Let's see. And then my last topic is if anyone wants to know about dark matter and how we know dark matter is real. Dark matter is an interesting concept. 80% of all the mass in the universe is invisible. And how we know that it's real is that we can look at every single galaxy. There is not enough mass in the center of any galaxy to keep everything orbiting around it. The sun has enough mass to it to keep the planets orbiting, but no galaxy has enough mass in its center, like the sun, to keep the whole galaxy together. So that means 80% of that mass, it's missing, and we don't know where it is, and scientists are on the look for it everywhere. They're trying to find this thing because they can look at all these galaxies and be like, okay, it's 80%, every single one of them, 80% of its mass is missing. Where is it? 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 So that's going to happen in probably the next 20 years, which I'm very excited about, what dark matter is.
Wait, but is it all orbiting the same thing? That has to be like
It's dark matter is at a grand scale. when things get so big that there's just a ton of mass missing. That like we need 4 times more mass in the center of our galaxy to keep everything orbiting around it.
Oh, then because orbiting.
Yeah, because yes, that's right. Because everything is orbiting in the Milky Way, there has to be mass in the center, and it's just not there. Yeah. Well, it's like it just doesn't add up because we can measure all the mass in the center of our galaxy, and we're missing 80% of it.
It's not enough to create
Exactly. But yeah. Are there any more last minute questions?
Can science quantify consciousness yet?
Huh?
Can science quantify consciousness?
No, because like that's a great question. But it's the fact that consciousness is witnessing itself, like we're self-aware, means that we can never be in a quantized state. Unfortunately. Unless you take a nag. Yeah, homework. Is that homework? Take a fucking nag. I think there's a question over here. Yeah.
So what happens to, because energy can't be destroyed, what happens to our energy when we die? Does that just go...
So, just like food breaks up in your body and releases kinetic energy, when you decompose, you release kinetic energy as well to the environment around you. And so then when you release that kinetic energy, it just gets released into the sky or into the earth, or something comes around and eats you up.
Yeah.
So the energy gets dissipated into something else. So the energy, if it goes into the sky, it goes into the wind, and then that energy gets carried on.
Is the energy always the same? Like, does that make sense? Like, every person who dies, will it always be the same type of energy?
Yeah.
Yeah. Okay.
So what's interesting about us is like, since you were a teenager, none of your atoms are the same. So you're built this consciousness, but none of the same material is the same, which is really fucking weird. So like everything that is on planet Earth has always been on planet Earth. So so what's interesting is most of every atom has been on every single place on the planet at least 6 times. So every single atom on your body has, traveled more than you ever will, which fucking sucks, and they do it for free.
It sounded like you were like not convinced by the Big Bang. Is that because you think there's like another hypothesis, or is it just like not enough evidence for you?
It's just not enough evidence.
Yeah, okay.
It's although I love telling people what we know.
Yeah.
It's just that if the Big Bang is as it is, that means that our universe is ever expanding, and that means it will just keep expanding infinitely, and that means everything is going to get further and further apart, and everything's just going to die. But the thing is everything in physics gets circulated and reused and recycled,
Yeah.
and it just doesn't make sense that the universe would just end.
Yeah.
No. Like, I believe that eventually it's just going to pull back down again. Right now, the only things that'll pull it back together again is if there be more mass. But unfortunately, there's not enough mass in the universe to pull the fabric of everything together. Yeah.